study of magnetoelectrodeposition of lanthanum chloride octahydride leached with sulfuric acid. This is our team. Arifo Gunawan Cahyanegoro, this is my name, and Dr. Sudibyo, Prof. Badarudin, Prof. Sugianto, Sir Fajar Zaman, Sir Yayat, and Dr. Arif Prasetya. Okay, the quick outline of this presentation, I think we have to start in introduction, and we share about experiment of this process, raw material that use, and discussion, conclusion. The last is references. Okay, about the introduction with lanthanum. Lanthanum is one of rare earth element that the distribution of RAE in the earth crust is much greater than gold. Yeah, as you can see in table 1, the distribution of RAE is about 60 until 66 ppm for cerium and 30 until 39 for lanthanum. Yeah, with a lot of resources, Indonesia have a regulation in Permen SDM nomor 25 that regulate to the industry or the business process in this country have to refine the lanthanum, the rare earth element until 90%. So the application for lanthanum itself is many application like low imaging for steel, hybrid carburized, and many electronics instrument like carbonate lightning and studio lightning. Yeah, the diesel application, the large resources of this lanthanum and rare earth element. So it is important to study the processing of this mineral. Okay, next slide. About the metal processing that we use is hydrometallurgy. It is different if we compare the pyrometallurgy that have a smelting process. So our study using hydrometallurgy because have a aqueous solution that we use is sulfuric acid. Yeah, we leach the lanthanum chloride. So we recovery using electrodeposition. Yeah, the previous study, Sudibyo 2020, show that the electrodeposition have a problem if we cannot make the electrolyte, the extraction of pure metal, the precious metal is low. Yeah, in this process, about 13 milligram per liter, that many impurity contained in this aqueous phase for this electrodeposition. Yeah, so our process, our study use the more purity raw material. It is a lanthanum chloride that we analyze in the next discussion slide. Yeah, electrodeposition itself is cathodic reduction. It is a simple explanation about electrodeposition to take a solid form solution. Yeah, it is the reaction, and the reaction that we want that not happen is the hydrogen revolution. Hydrogen revolution usually occurs in electrodeposition and have a problems like the porosity, like the weakness of the solid deposit that result it's not that we want. MAD, magnetoelectrodeposition, can help to removing the hydrogen revolution. The magnetoelectrodeposition also aims to fix the problem that often arise in electrodeposition, like the roughness of deposit and for smoothing the resulting surface. So we propose that with use magnetoelectrodeposition, there is dipole configuration. There is if we can listen the magnetic field on the lanthanum process, the direction of the magnetic field will be the same direction. So yeah, with this addition, it will produce the same direction magnetic. So the limiting current value will increase and the electrodeposition process more efficient. Now, this is the slide of experimental our process. We perform the lanthanum MAD process with the parameter like this. The lanthanum sample used is lanthanum chloride, heptahydride, and the result performed at research unit for mineral technology Lampung. Okay, about the diagram, I think we start to characterization of lanthanum that we use. Then we reach the lanthanum chloride heptahydride at a certain sulfuric acid. We analyze the density, we analyze the viscosity of the electrolyte, and after that we do the process magnetic electrodeposition in 75 milliliter electrolyte. Yeah, it is the schematic. Yeah, dependence on C, dependence on B, the magnetic field, dependence on E, electrodeposition area, and dependence on diffusion. Okay, this is the result of X-ray diffraction, so that the dominant compounds present in lanthanum chloride is lanthanum oxide, chlorine monoxide, and hydrogen monohydride. From the XRD graph in figure 5, it can be seen that the graph has a slight peak because the raw material is close to pure. Meanwhile, the lanthanum metal content in the material was 60%. So we have to refine this lanthanum like the regulation of Permen SDM that regulate the element have to 90%. So this is the result of LSV. LSV is a voltammetric technique. We scan from a low potential to high potential, and with figure 6, we see the increasing limiting current occurs due to the increasing in mass transfer in MAD process. Yeah, the MHD or magnetohydrodynamic presence due to the presence of magnetic field. So in 600 Gauss or 0.06 Tesla, there is a significant increase in limiting current. And in the figure 7, we can see the increasing concentration of electroactive in this process is lanthanum can also increase the limiting current because we see in this induction turbulent flow facilities mass transfer, so that the greater the electroactive concentration, also the limiting current value also increase. Yeah, and our result for the next is working electrode. Yeah, the larger the working electrode area, the greater the efficiency of steering magnetic in the diffusion area. But for the concentration of sulfuric acid, we see that the viscosity is larger, is increased, but the limiting current value will decrease. Yeah, we see that 3 molar is optimum because sulfuric acid does increase the leaching process become faster. However, for the MAD process, it is efficient at 3 molar because there is a significant decrease at 5 molar, I think, and it's wasting the material of sulfuric acid. Okay, this is the sample of the chronoamperometry. Yeah, analysis for the diffusion coefficient. Yeah, we use the formula from the graphic Kozel plot that we have. Yeah, like this. Then we see that with the addition of sulfuric acid, the diffusion coefficient will decrease. Yeah, we have conclusion. So the results show that electrode area, magnetic field, and electroactive concentration give an increasing the limiting current value, but the sulfuric acid, the viscosity, the diffusion coefficient will decrease the limiting current value. Yeah, it is. I think it's enough. This is the references that we use, and this process supported by Indonesia, by LIPI, Indonesia Institute of Science, through a national priority research. Thank you for the support, and thank you for all.